Picture this. Billions of devices chatting across the globe, web pages loading in an instant, and apps pulling data like it's second nature. What's the secret sauce behind this digital symphony? It's the HTTP protocol, the invisible force driving the internet as we know it. In this video, we are peeling back the curtain on HTTP, what it is, how it powers your online life, and why it's one of tech's greatest unsung heroes. Buckle up, we are about to take a deep dive into the engine room of the web. HTTP stands for HyperText Transfer Protocol. It's the rulebook that decides how your device, whether it's a smartphone, laptop, or even a smart fridge, talks to servers hosting websites, apps, and services. It's the system that delivers everything from memes to online shopping carts, dreamed up by Tim Berners-Lee back in 1989 when he kick-started the World Wide Web. Let's explore how this tech marvel works. At its core, HTTP is all about communication. It follows a client-server model. The client, usually your web browser, sends a request to a server, which is a powerful computer hosting a website. The server processes that request and sends back a response. Simple, yet elegant. This back and forth is happening billions of times a day across the globe. Let's break it down step by step. Imagine you're ordering food at a restaurant. You, the client, tell the waiter what you want. That's the request. The kitchen, the server, prepares your meal and sends it back. That's the response. HTTP works in a similar way. Here's how. When you type www.example.com into your browser and hit enter, your browser creates an HTTP request. This request is a message with specific parts, like a digital postcard. It includes a method, a URL, headers, and sometimes a body. We'll get into those in a moment. Now, this request travels over the internet, hopping through routers and networks, until it reaches the server hosting example.com. It's fast, usually taking just milliseconds. The server reads the request, processes it, maybe fetching a web page or querying a database, and crafts a response. This response includes a status code, headers, and the requested data, like an HTML page or an image. The response zips back to your browser, which renders the web page for you to see. Boom! You're now looking at cat videos or your email inbox. Now, let's talk about those HTTP methods I mentioned. These are like the verbs of HTTP. They tell the server what you want to do. Here are the big ones. Get, the most common method. It's like saying, "Hey server, give me this web page." It's used to retrieve data. Post, this one's for sending data to the server, like submitting a form with your name and email. Put, used to update something on the server, like editing a blog post. Delete, pretty self-explanatory. It asks the server to remove something. Head, similar to get, but it only fetches the headers, not the full content, handy for checking metadata. There are others too, like patch or options, but these are the stars of the show. Every time you interact with a website, these methods are quietly doing the heavy lifting. Let's zoom in on what an HTTP request and response actually look like. They're just text, but they're structured like a well-organized letter. This is HTTP request. The first line has the method, get, the resource, index.html, and the HTTP version, 1.1. Then come headers, like host and user agent, which give the server extra context. Next is response. The first line includes the status code. 200 means success. Headers like content type tell the browser what's coming, and the body contains the actual data. Those status codes are super important. They're like the server's way of saying, "I got you," or "Oh, something's wrong." Here's a quick rundown. 200 OK means everything worked perfectly. 404 not found means the server couldn't find what you asked for. Think page not found. 500 internal server error means the server's having a bad day and messed up. 301 moved permanently means the resource moved to a new URL. 403 forbidden means you don't have permission to access this. There are dozens more, but these are the ones you'll see most often. HTTP has evolved over the years. Let's take a quick history tour. HTTP 0.9, 1991, the original version. Super basic, just for fetching simple web pages. Next is HTTP 1.0, 1996, which added headers and status codes, making it more versatile. Number 3 is HTTP 1.1, 1997, introduced persistent connections, meaning the client and server could reuse the same connection for multiple requests. Still widely used today. Number 4 is HTTP 2, 2015, a major upgrade with multiplexing, allowing multiple requests and responses at once, and compression for faster performance. Next on the line is HTTP 3, 2020s, which built on UDP instead of TCP, using QUIC for even faster, more reliable connections. It's the future. Each version made the web faster, more secure, and more efficient. So where do we see HTTP in action? Everywhere. When you stream a movie on Netflix, shop on Amazon, or scroll through social media, HTTP, or HTTPS, is working behind the scenes. APIs, those tools that let apps talk to each other, rely heavily on HTTP too. It's not just web pages, it's the glue holding the modern internet together. Thanks for watching this video. If you like this video, give it thumbs up, share it with your friends, and don't forget to subscribe to the channel.